Hey everyone, welcome to Unit 3, Lesson 1, Rate of Change and Slope. In Unit 3, we're going to be talking a lot about linear equations and graphing lines. So let's get started. So first we're going to start talking about the rate of change. So what is the rate of change? Well, the rate of change is a ratio, also known as a fraction. These are synonyms. It's a ratio or fraction that shows how one variable, y, changes with respect to the other variable, x. So how is one variable changing with respect to the other? On a linear graph, on a line, that is called the slope of the line. How one variable, y, is changing with respect to the other variable, x. Slope is written as a ratio or as a fraction. It means the same thing, okay? Slope is written as a fraction of the vertical change, which is the rise, that's the vertical change, to the horizontal change, which is the run, horizontal run. So you can think about between any 2 points on the line. So you can think about rise as a vertical change. Rise is, going up or down, and run is like, like a person running. We run horizontally, okay? So the slope is written as a fraction or a ratio of the vertical change to the horizontal change between any 2 points on a line. And that slope remains consistent or constant for any 2 points on the same line. So if you're looking at a line like this one right here, the slope is the same between any 2 points. That's what makes it a nice straight line, as opposed to a line that looks like, jagged, because the slope keeps changing between the different points. So in a nice straight line, the slope is consistent throughout. The slope is written as a ratio or a fraction in simplest form, so reduced as much as you can. And the popular variable for the slope in all mathematics, the variable that we use to represent slope, is m. We have 4 different types of slope, and to read the slope of the line, you want to read the line from left to right always, okay? From small to large, from left to right, from least to greatest, just like an interval notation. So to read the type of the slope, we read it from left to right. So the first type of slope, if we look at this line from left to right, we see this line is increasing or going up from left to right. So that is a positive slope. In the next type of slope, take a look at this line. We read this line from left to right, and it's going from left to right, it's going down. So that is a negative slope. This line from left to right, nothing's changed, so there's no change, which means the change is 0, which means the slope is 0. And the last one, which is actually interesting, you can't really read it from left to right because it's only going up and down. So it's not a slope of 0 because we saw from left to right here, this didn't have any change, so that's 0. But this you physically cannot read from left to right, so that slope does not exist. We know that as undefined slope. Throughout this unit, there's going to be different ways in which you're going to learn how to identify slope. The first way you're going to learn is how to find the slope from a graph. So keep in mind that m is the variable for slope, and slope is the same as rise over run. Oh, I know how to spell. Rise over run. So always checking the rise over the run. And here's how we do it. You take a look at your line, and you find 2 what I call pretty points on the line. Pretty meaning they're on this nice corner that you're able to tell what numbers they're on. So we identify those 2 points on the line, and sometimes they're marked, and sometimes you have to mark them. And you figure out from one point to the other, how much do you rise and how much do you run. And you almost end up making a perfect letter L of sorts, whether it's upside down or right side down. It's like a perfect letter L, or what we call a perfect 90-degree angle. So how much did we rise and how much did we run? So here, to get from point A to point B, we rise 1, 2, 3, 4, 5, 6, 7. So we rise 7, and we run 1, 2, 3, 4. we rise 7, and we run 4. So the slope of this line is 7 over 4. So to get from this point to the next point, wherever this point may be, you would rise 7 and run 4. Notice that the slope is positive because from left to right, the line is going up. It's a positive slope. So let's take a look at the next one. We want to grab our 2 pretty points, and we see here that we're not actually rising to get to this point, but we are rising down, which kind of should symbolize that the slope should be negative because you have to go down and then over. So let's draw the pattern here. Let's draw that 90-degree angle. We got to go down this much, over that much, make our nice 90-degree angle. So we rose, or we went down 2, 3. We went down 3, and we ran 1, 2, 3, 4, 5, 6, 7, 8, 9. We ran 9. Okay, we did run to the right, so that is positive, but we went down, so that is negative. So our slope is -3 over 9, or -1 over 3. And that makes sense that it's negative because our line is going down from left to right. For number 3, if you remember from above, you know that the slope is 0. But let's use rise over run to prove that even further. Notice to get from point A to point B, I don't rise at all. I don't rise this way or this way, but I just run in this direction. So I have no rise and 1, 2, 3, 4 steps of run. So my slope is a slope of 0. Now we can compare that to number 4, which we know the slope is undefined because we saw that in the notes earlier, but let's further prove why it's undefined using rise over run. Now, to go from point A to point B, I'm going to rise down 1, 2, 3, 4, 5, or you can rise up from here to here, 1, 2, 3, 4, 5, whichever you want to call it. Let's call it +5. You can call it -5 if you'd like. But you're not running any amount. It was all rise and no run. And anything divided by 0 is undefined. So compare and contrast number 3 and number 4. Notice how this was all run and no rise. So our no rise and our all run. And 0 divided by 4 is 0, which makes what's called a horizontal line. In the vertical line, we had all rise and no run. Here's your all rise because it's going up, and no run because literally it's just going up. It's not increasing from left to right, it's just straight up, going straight up. And a number divided by nothing is undefined. 5 divided by 0 is not a thing. You can't take 5 candies and divide it by 0 people. That's not the definition of division. So this makes an undefined slope, and that's attached to, here it is, that's attached to a vertical line. So go ahead and take some time to do the odd problems on the second page of the notes. Pause the video, and then when you unpause the video, you can check your answers with mine. Do that now. So now that you have completed the problems, here are the solutions. For 5, 7, both have positive slopes. 9 has a negative slope of -3/4. 11 is undefined, that's a vertical line, which is all rise and no run. 13, +1/4. 15, another positive slope of 1/3. 14 would be a negative slope. I know you didn't do 14, but I just want to give you another visual of a negative slope. And I know you weren't asked to do 16, but 16 is a slope of 0, no rise, all run. 0 divided by a number is 0. Horizontal lines have a slope of 0. Moving on in our conversation about slope, you just spent some time in being introduced to slope, and you were finding the slope using a graph. Now we're going to find the slope using some mathematics. And in order to do that, we need to know the formula for the slope. The slope formula is used to find the slope between 2 points on a line. And we call those 2 points x1 and y1 and x2 and y2. And the reason why we call them 1 and 2 is just to keep them organized. This is the first points and this is the second point. So the formula for the slope of the line is m equals y minus y over x minus x. Now, you've probably heard y2 minus y1 over x2 minus x1. I'm here to tell you that it really is the difference in the y's over the difference in the x's. Just make sure that if you're going to pair this y, or put this y first, that you must put this x first. And if you're going to put this y second, then you must put his x second. And note that it is important to simplify your answer because slopes are simplified fractions. So let's find the slope in number 1. Find the slope between each pair of points. So I'll call that m. M is equal to, let's take this y first, so y minus y over x minus x. Okay, so y minus y over x minus x. If you're going to do the first y, then you have to do the first x. And that's 1 minus 3 over 1 minus 4, which is negative 2 over negative 3, or positive 2/3. So if a line passes through these 2 points, the slope is going to be 2/3. Let's try number 2. Our slope is equal to 4 minus negative 2. So notice how that second y was negative, so we had to write 4 minus negative 2. Y minus y over x minus x. Again, y minus y over x minus x. Now that we've set up our rise over our run, or our y minus y over x minus x, we're going to do the arithmetic to get 6 over negative 12 to get a slope of negative 1/2. Let's take a look at number 5. So slope is equal to y minus y over x minus x. So again, y minus y over x minus x. That gives us 0 over 2, which is slope of 0. So since the line that passes through these 2 points has a slope of 0, then that line has got to be a horizontal line. So take a moment to try on your own numbers 8, 9, and 10, and then I will provide you with the answers after you try them by yourself. Now that you have tried 8, 9, and 10, here are the answers for those problems, and we're going to go ahead and try our next set of examples, which requires us to go backwards. So this is where the fun algebra kicks in. So sometimes you must complete the ordered pairs using a given slope. So here we're going to have to use our algebraic skill set. So here's an example. If the slope of the line passing through the points negative 5, 6 and 5, y is negative 4/5, find y. So what did they tell us? They told us that the slope is negative 4/5. We know that because it says if the slope of the line, blah, 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 is negative 4/5. And then the 2 points that they gave us to reference were negative 5, 6 and 5y. So those are the 2 points, and this is the slope. If we take our equation, m equals y minus y over x minus x, we can use that equation to find the missing variable. So again, the slope that they gave us is negative 4/5. That is the slope of the line that passes through the points negative 5, 6 and 5, y. So let's set up the slope equation. Negative 4/5 is equal to y minus y. So y minus 6, I started with this y just because I did. So y minus 6 over, so I have to start with this x, over 5 minus 5. So let's look at that equation set up one more time. They gave us the slope as negative 4/5, and they gave us the 2 points that compose that slope in the line. So I said negative 4/5 is equal to y minus y over x minus x. Now that I have this set up, it's an equation, and I'm simply solving for y. So let's start fixing this up. Negative 4/5 is equal to y minus 6 over 5 plus 5, which is 10. This looks like a proportion, and I can solve this proportion by setting the cross products equal to each other. See how everything comes back? So negative 4 times 10, which is negative 40, is equal to 5 times y minus 6. And there's our proportion set up. And now I will simply solve for y to get a final answer of y is equal to negative 2. So solve for y by distributing the 5 and then isolating the y. Let's try another one of these examples. Find the missing value using the given slope. So our given slope is 2. And here are the 2 points. And it looks like we are solving for a missing x. And that's okay. We're going to use the equation, the slope equation, m is equal to y minus y over x minus x. That slope equation is going to give us the relationship between these 2 points and this slope. And that relationship will help us find our missing value. So let's set up. We know that the slope is 2. So 2 is equal to, all right, let's grab our y's. Which one do we want to start with? Let's start with negative 2. Y minus y, so negative 2 minus 6. Y minus y over x minus x. Negative 3 minus x. Okay? And now remember, one thing that's important is that slope is always a fraction, but that's a 2. So how do I write 2 as a fraction? Well, I write it as 2 over 1. So let's clean up in the numerator, because I can clean this up, and rewrite this as 2 over 1 is equal to negative 8 over negative 3 minus x. Now that I have it set up like a proportion, I could do my cross products. 1 times negative 8, which is negative 8, is equal to 2 times negative 3 minus x. 2 times negative 3 minus x. Now we'll solve for x by distributing the 2. So negative 6 minus 2x. Add 6 to both sides. That will zero out to make negative 2 is equal to negative 2x. Divide by negative 2 on both sides. And negative 2 divided by negative 2 gives us an x equal to 1, which means that this missing coordinate is a 1. Okay, to finish off here, go ahead and try 14 and 15. Pause the video, and then I'll give you the answers. All right, so for number 14, the way I set it up, you could have set it up differently. Just know that it has to be y minus y over x minus x, as long as you have them correct. But if you set it up, the correct answer is x equals negative 2. And for number 15, the correct answer is y is equal to 5. So the biggest takeaway here is remembering that the relationship between the slope and the coordinates is what gets you the equation to help you solve for the variable. And if your slope is written as a whole number, make sure you write it in fraction form, 2 over 1, for example, here, so that you can set up your cross products after you clean up in the numerator or the denominator, the ones that has the 2 numbers. Thanks for watching. Thanks for learning.